Good day to you all. Today we're learning one more problem from the previous year question paper, which is of Jan 2026 of ML subject. And the problem number is 10A, which is of 12 marks. Explain the k-means cluster algorithm and solve the following problem. They're given the points A to G, that is 1, 1, 1.5, 2, 3, 4, 5, 7, 3.5, 5, 4.5, 5, 3.5 and 4.5. And let's apply k-means with the k equals to 2. That is a given problem which is of 12 marks. Okay, the solution is like this. So here this is a given k as 2 and this is the data points. So what is k-means? It's a clustering algorithm which groups the similar data points into the clusters. Okay, and each cluster has a centroid and it divides the data into two. That is two clusters we have to consider, right? So here first we have to choose the number of clusters and select the initial centroids and calculate the distance between each centroids and assign the points to the nearest clusters and recalculate the centroid. Then again repeat until the centers do not change. So these are the steps to follow in the k-means algorithm. So initially we are considering here A is as 1.1, and 5, 7, which is the data points A and B. Okay. Again here we are using the same distance Euclidean distance formula. D is equals to square root of x2 minus x1 the whole square plus y2 minus y1 the whole square, which is used to find the distance between the points, existing points, right? So when you calculate the distance between the two given centroids, that is considered values 1, 1 and 5, 7, that is the data point A and the D. Okay, so here when you calculate the distance between A and A, it will be automatically 0, and the next point A with the D, that is 1 minus 5 minus 1 the whole square and 7 minus 1 the whole square, that is 4 square plus 6 square, 16 plus 36. So automatically you will get the root under that value will get is 7.21. So like that you have to find the distance between the given data points, 1.5 minus 1, 2 minus 1, like that. So you have to find the distance for each and every values. In that, which is a nearby distance, you have to find out. So in the first data points, 0 is the minimum value, so the centroid cluster will be C1, and here again it belongs to the C1 since the minimum is the C1, and again here it is similar, so we are considering the C1, and again here it is 0 is the minimum, so it is C2, and in this minimum is 2.5, so C2, and again it is C2. So like that, which is the minimum value will be there, that will belongs to that, will throw the value, means that point into that particular clusters. Okay, assign that values. So here after finding that particular centroid clusters, that we have to find the centroid for the data points. Okay, so we consider that ABC belongs to the single first cluster C1, then that data points we have to kind the centroids, that is the values of all the x coordinates and y coordinates you have to add divided by number of points. Okay, so this is how you have to solve. So you'll get the points as values as 1.8. So what you have to do is 3 plus 1.5 plus 1 and 1 plus 2 plus 4 divided by 3 you have to do. So that's how you got these two values. The same way for the centroid, below centroids D, E, F, G, the 4 below points you have to take the coordinates. Okay, then this is the value for the centroid 1 and centroid 2 for the given two clusters, and this is the final answers, where the cluster 1 contains 3 data points with the centroid and the cluster 2 contains 4 data points with the centroid. Okay, so here the k-means divides data into the clusters based on the similarity, and similarity points are grouped together, and the algorithm stops when the clusters no longer changes. I hope you have understood. Thank you.